Okay, here's the question then. Just move it across here to get it all in. There it is there. So I've summarized it here. So let's have a go at it then. Curve C is given by this parameters. P lies on C and has parameter P. Show that the tangent at P is this. Okay, so the tangent at P, so we'll need the x dt, won't we? X equals AT and y equals B over T. So x equals AT, y is equal to B over T. So dx dt then we need, don't we? So dx dt differentiate with respect to t, and that's A. The y dt, differentiate this is something to the minus 1, isn't it? T to the minus 1, so it's minus b, t to the minus 2. So that's dy dt. So dy dx then is equal to this divided by this, isn't it? So it's minus b over t squared divided by dx dt, which is A. So we've got that. At P, the parameter P, we've got, this is the point AP and B over P. Tangent is so y minus the y value, B over P, is equal to the gradient here, minus B over AP squared. Okay, times x minus AP. So there's our equation. Now let's look up here. So we better multiply by this and expand it and tidy it up. See if we get the same. So multiply through by AP squared then all the way through. Move this up basically to times. We get AP squared y minus A, and one of the p's cancel, times B is equal to minus bx. So we're expanding this bracket plus ABP. So that tells us now then that AP squared y plus bx, so I've moved that over, and then we've got minus another APB, so 2ABP, because they're both the same, aren't they? But that becomes minus another, so it's minus 2 lots of equals 0. So what do we get? Yeah, we got that there. That's what we wanted, didn't we? Same thing. The tangent at P meets the x-axis at A and the y-axis at B. Find the area at A or B. So this tangent meets the x-axis at A. So at A, x-axis, so y is 0, gives, that would be 0, bx equals 2abp, so that tells us what x is. Divide by b, both sides, 2ap. At the other point B, this is the y-axis, so x equals 0, gives, so let's just check that B was the y-axis. X-axis at A, y-axis at B, so here the y-axis x is 0. So at B, so put that in here then into the tangent. This is AP squared y, x is 0, equals, move this over to ABP, so it tells us what y is. Y is equal to, an A will cancel, one of the p's will cancel here, and we're left with y equals 2b over the p that's there, times. Okay, good. 2b over p, that's good, so that's y. So basically here's our axes. A, y is 0 and x is 2ap. Here's the origin, and that was A. And B, x is 0 and y is 2b over p. And this is the point B, and we got our triangle. So area AOB then is equal to half base, which is half of 2AP, times the height, which is 2B over P, which is equal to then, the P's cancel, the 2 cancels, and we're left with 2AB. So that's our area, units squared. Okay, D, 2AB is the point here. Show that there is no point P on C, such that the tangent to C at P passes through D. So 2AB, let's put 2AB in. D, 2AB. This is part C now. I think this was part B here, wasn't it? And then part A was at the top here. Okay, so D, does that go through the tangent? Does the tangent go through that point? So here, for the tangent to go through that point, we would need this to be satisfied, wouldn't we? So AP squared y times y value, which is b, plus b times the x value, 2a, minus 2abp equals 0. So is there a value of p? So let's just check that 2a is the b is the y value, ap squared by, 2ab, when we put it in here, the x is 2a, minus 2abp, that's good. So what have we got? We've got abp squareds minus 2abp plus 2ab equals 0. So let's have a look at the discriminant here. B squared minus 4ac is equal to this minus 2ab squared minus 4 times this a, which is this value, and times c, which is this value, 2ab. 4a squared b squared minus 8a squared b squared, which equals minus 4a squared b squared, which we know is less than 0 since a and b are positive. Okay, that's good. So there's no solutions. So no solutions. And that's what we wanted to show, because there's no value of p now that satisfies this quadratic. And if that's the case, then this point doesn't lie on the line.